All right, let's take logarithm equations one step further and actually solve for them. First, we'll do a little bit of review and make sure we understand what we can do with logs. Okay, go ahead and try these three on your own. There are 6, so let's try these 3 and then we'll move on. Convert them into equivalent exponential equations. As a reminder, we know that log base b of x equals L, therefore b to the L equals x. I'm going to push pause. There are the first 3. Go ahead and push pause and check your work. Let's try the next 3. Here are the next 3. I thought I'd point this one out as a reminder. Natural log is base e. So we can say e raised to the 0 power equals 1. And this one's going to be very similar to the ones that we're going to solve today. I've got a base 10 raised to the 3rd power. I can actually solve that for x. All right, we just have a lot of examples with this section. So I'll talk through the first one and I'll let you solve quite a few on your own, okay? So here it says write each of the following equations as an equivalent exponential equation and solve for x. So we have base 10 here. I can say 10 raised to the 0 power equals 3x plus 7. Now I can just go ahead and solve for x. 10 minus 7 is 3. Divide both sides by 3. I have x equals 1. Again, change it to exponential. 2 to the 4th power equals x plus 5. 2 to the 4th power is 16. Subtract 5 from both sides. X equals 11. One more. Okay, this one's a bit trickier, right? Remember, if I've got addition in between, it's the same as multiplication. Go ahead and FOIL that. Well, let's take it out of its log version first, and then we can FOIL it. This is a 10. So 10 raised to the 1st power equals x plus 2, x plus 5. 10 equals x squared plus 7x plus 10. I just FOILed it. You should know how to do that by now. I've got 10 on both sides. Zero equals x squared plus 7x. I could factor out an x. X plus 7. Therefore, I can solve. I've got x equals 0 or x equals negative 7. Now, we need to make sure that none of these are extraneous equations, extraneous answers. So we need to plug these back in to make sure we don't get a negative. So if x equals negative 7, we plug that into the x plus 2 equals a negative 5. I also need to plug it into the other binomial, x plus 5, negative 7 plus 5 equals a negative 2. So both logarithms in the equation are undefined. Therefore, x equals negative 7 is called an extraneous solution. So only x equals 0 is a valid solution to the equation. So whenever you get 2 answers, you need to go ahead and plug them back into the original problem and make sure you don't get any negatives, because you can't take a log of a negative number, right? Okay, exercise. So Drew said that the equation log base 2 of x plus 1 raised to the 4th power equals 8 cannot be solved because he expanded x plus 4 to the 4th power and realized that he cannot solve the equation, all of that raised to the, he cannot solve this equation. Is he correct? Explain how you know. Well, let's try our rules of logarithm to solve this part of the equation and see if we can get it. I'll rewrite this down here. Log base 2, x plus 1 to the 4th power equals 8. Now I'm going to use our little trick of exponents. I can drop that over here. Let's see if it all works. So 4 log base 2 of x plus 1 equals 8. Now I can divide both sides by 4. Sort of cool. Log base 2 x plus 1 equals 2. Now it's much easier, isn't it? 2 raised to the 2 power. X plus 1, 4 equals x plus 1. X equals 3. Got it, right? So let's check the solution, put it back into the equation. Log base 2, 3 plus 1 raised to the 4th power equals 8. Log base 2 of 4 to the 4th power equals 8. Okay, 4 log base 2 of 4. So that gives me 4 times 2 equals 8, which is in fact a solution. We got it. All right, solve exercises 2 through 4 for x. I'm going to do 1 or 2 of these, and then you're going to start tackling a few of them on your own. Here I'm going to drop that power in front again. So 5 natural log 4x equals 15. Divide both sides by 5. Natural log 4x equals 3. Now we can say e to the 3rd power equals 4x. Divide both sides by 4. X equals e to the 3 over 4. You can go ahead and crunch that into your calculator or circle it, right? Now, we do need to get into the habit of checking for extraneous solutions. Because the solution is greater than 0, we're good. It's not going to be extraneous, okay? So it is defined. Let's try the next one. I have a power again, so I'm going to plop that in front of the log. 2x plus 5 equals 4. Divide both sides by 2. Log base 10, 2x plus 5 equals 2. So 10 squared equals 2x plus 5. Go ahead and expand that. I'm going to subtract 5 from both sides. I've got 95 equals 2x. X equals 95 over 2, which you can calculate or circle it. And once again, I plug that back into the original equation. Two times 95 over 2 plus 5, I'm right here, is greater than 0. So we're good. It's a defined solution. Okay, you go ahead and try this one. I'm going to push pause. All right, I got x equals 1/5. I plugged it back into the original log. I'm a positive, positive interior. My binomial is positive, so we're good. My solution is not extraneous. All right, here's where things get just a tad bit more complicated. You're going to have to remember some of your algebra rules. It'll be good though. So we're always going to see some things that we remember from our properties of logarithms, and our ability to rearrange equations is going to have to be a bit stronger. Okay, now remember for this one, I see that I have 0 on one side of the equal sign and a subtraction here with 2 logs. Now if you remember back to a few lessons ago, if I've got log of something on one side of the equal sign and log of something on the other, I can just solve whatever the log is of. Okay, that's a little reminder, a very, very basic reminder. So let's try this one. I'm going to move this to the right side of the equal sign. Because it's 0 over there, it's pretty easy to do. I've got log x plus 4. Since I have log on both sides, I can get rid of them. So now I have x squared plus 7x plus 12 equals x plus 4. Six x minus 4 minus 4, 8. Now I'm back to 0, so I can factor that. It gives me x plus 4, x plus 2. So x equals negative 4 and x equals negative 2. And I'm going to have to check both of these to make sure they don't give me any negative logs. So I'm going to put in negative 4 first. Negative 4 squared plus 7 times negative 4 plus 12. I've got 16 minus 28 plus 12, 18, 28. That gives me 0. So that doesn't work. Now let's try negative 2. Negative 2 squared. That is a 4 minus 14, which is negative 10, plus 12 is 2. So that is our only answer. Cool? I'm going to show you one more way to work this problem, but I'm going to push pause and do it. So hold on a second. I used a different property of logarithms for this one. When I have subtraction in between 2 logs, I can change it into a division problem. Still get the same answer, so it doesn't matter which way you use or which method you use, which property you use. Let's try another one. Okay, tad bit harder, but I've got addition in between them, so I can change that into multiplication. Oops. Log base 2 of 3x times 4. So 2 to the 4th power equals 12x. 2 to the 4th power is 16. Divide both sides by 12. I have x equals 16 over 12, which reduces, let's see, 8 over 6 or 4 over 3. Cool? Okay, since 4 over 3, if I plugged it back in, it's always greater than 0. It's not an extraneous solution. But let me show you one more way. Okay, there's always one more way. I've got log base 2 of 3x. This one right here simplifies to 2. So 2 to the what power equals 4. The what power is 2. Subtract 4 from both sides. 2 squared equals 3x. 4 equals 3x. X equals 4/3. Same answer, different method. Doesn't matter which one you use. Okay, try this one. Natural logs, it's a little different. You can either move the natural log to the other side of the equal sign and both the logs cancel out, or you can change it into a division problem. Either way, you'll get the same answer. I'm going to move it over to the other side of the equal sign because that's how my mind works. I'm going to change this into natural log x plus 2 squared equals natural log of negative x. X squared plus 4x plus 4 equals negative x. X squared plus 5x plus 4 equals 0. Factor that, x plus 1, x plus 5, nope, I need a x plus 4, sorry. Blip in my factoring skills. So x equals negative 1 or x equals negative 4, and yes, we have to check both of those. I'm going to plug them into here, make sure I don't get a negative answer. So negative 1 plus 2 is 2. I'm good. Negative 1 gives me a 1. So I'm good with both of those. Now let's try the negative 4. Negative 4 plus 2 is negative 2. That doesn't work. So it really doesn't matter. So x equals negative 4 is called an extraneous solution because it gives us a negative answer. So the only solution is x equals negative 1. Okay, this one's a tad bit more complicated. We haven't had one like it. But I'm going to move all the logs to the left side of the equal sign. And then we can change the addition into a multiplication. And the whole numbers to the right side. So this gives me log x squared equals 2. So 2 log x equals 2. Divide both sides by 2. So log x equals 1. So 10 to the first power equals x. X equals 10. If I plug it back in, I'm good, because 10 is greater than 0, so no extraneous solutions. Really quick though, another way I can look at this one, I don't have to change this into a multiplication. I can say that log x plus log x is actually 2 log x. Okay, it's just like adding variables. So x plus x would be 2x. But I changed it into a multiplication and still got to the same spot. All right, last one. I'm going to get all the variables to the left side of the equal sign and keep the whole numbers to the right so I can use some of my properties. So I have log x plus 2 plus log x plus 3 equals log 12. Change this into a multiplication problem. X plus 2, x plus 3. Now, that's really the easiest thing to do. Okay? And then I'll FOIL x squared plus 5x plus 6 equals 12. Subtract 12 from both sides. Minus 6 equals 0. I just did that. Oh, if you could read it. Now I can FOIL x minus 1, x minus plus 6. So x equals 1 and x equals negative 6, and I have to check. 1 is good. It's a positive number. I'm going to get positive logs for that one. Negative 6 though. Negative 6 plus 2 is negative 4. That doesn't work. I don't have to check the other one, but it also doesn't work. So negative 6 is an extraneous solution, and I only have 1 as my actual solution. That's it. I hope you guys got insight into solving logarithmic equations. There's lots of different ways you can handle them, and it's just going to take diving in to try some things. Good work.